Saxon, Algebra 2, Lesson 110. Welcome, my students, to a lesson that is not mathematically complicated, but it's a little bit of a mind bender, okay? So just work with me on this, and it'll make sense in the end. There are two lessons that go together. 110 and then 112 is going to be very similar. So by the time we get to the end of 112, this should be feeling a little more comfortable in your brain. The topic is quadratic inequalities. And I'll explain what that means in just a minute. Lesson 110 is going to focus on greater than. Okay? And then lesson 112 less than inequalities. So we're breaking them out into different lessons, and you'll see why in just a minute. Okay, what we have graphed up till now, we've graphed a lot of inequalities, but we haven't graphed quadratic expressions. A quadratic expression, remember, is in the form of, you've got an x squared term and an x term and a c term. So we're going to graph things in this format. We've never done that before. We've always just graphed where it's just x plus 3 or whatever, right? So this is different. The first one John gives us has some training wheels on it, because what he does, he tells us graph this on a number line. This is just number line graphing. It's not the grid system. And this one, this quadratic expression that he's giving us, he's already factored for us. So, way to be cool, John. Okay, so there's our quadratic expression that we're going to factor, and the domain is going to be the reals. Okay, so as soon as we see that, we imagine our picture, it's arrows and lines, it's not polka dots, all right? So, that's good to know. I feel like my brain automatically goes to reals. When the domain is integers, that's when I have to think a little harder. Okay, so what we're looking for is values of x that will make this expression, this inequality, come true. And notice that we're greater than 0. Okay, so let's stop and look at what's happening here. These two things are factors, right? This is one factor, this is the other factor. They're being multiplied together, and the answer is greater than 0, okay? What that means is that this factor and this factor, we want them to result in a positive number, right? Because a positive number will be greater than 0. So this is two things being multiplied together, and we want them both to be positive. There are two ways we can do that. Either this factor is positive and this factor is positive, because positive times positive equals positive, or they could both be negative numbers, right? Because a negative times a negative comes together and also makes a positive. So we have two possible scenarios here. The positive scenario and the negative scenario. Okay, this is where your brain starts to go, wait, what is she talking about? And I'm talking about the factors that we need in order to make this come true, right? In order for this expression to be greater than 0, this has to be a positive number. And playing around with the signs, there are two ways to get that to happen. Either both of these factors are positive or both of these factors are negative, because that will also give us a positive. So those are the two scenarios I've set up here. This one, the positive, and over here, the negative. All right? So now I'm not paying minus 0, or greater than 0 anymore. We've already accounted for that. We've set up these two scenarios so that both of these answers will qualify as being greater than 0. So I'm not paying attention to this inequality anymore. Now I'm putting my attention on these two columns. This first column represents the first term. If we want x plus 2 to be a positive number, then it has to be greater than 0. Easy, right? I mean, that makes common sense. If we want this to be a positive number, it has to be greater than 0. If we want this to be a positive number, then it also has to be greater than 0. Okay? Now, we're simply going to solve these two values for x. So here we do, it's simple algebra. X is greater than minus 2. X is greater than 3. Okay? And now let's draw a simple graph of that. Here's negative 2, here's positive 3. I'm not even going to put anything else on it. So, this would look like that. This would look like that. So in order for both of these things to be true, this is the place where they're both true. All right? So this is one answer for the values that will make this term be equal to 0, which, be a positive number, which will make this true. All right, so this is half of our solution. Now we go over here and say, okay, what if we have two negatives? So what we do is we say x plus 2 would have to be less than 0. Again, we're not paying attention to this anymore. This we've taken care of. We're just saying, how would we make this first clump be a negative number? We want it to be negative. Well, it would be less than 0. And we want the second one to be negative. So that would also be less than 0. Okay? Now we do a little bit of algebra. And we draw a picture of this pair of solutions. Because in order for this whole scenario to work, both of these things would have to be true. So again, here's our 3, and here's our minus 2. There's that solution, and then there's that solution. So in order for this to work, this would be the place where our solutions meet. And now, what we're going to do is draw one graph to put both of these answers on. We're saying that if x is greater than 3 or less than minus 2, this quadratic inequality will be true. These are all solutions for our quadratic. And this is on the bottom of page 448, and this is the right answer. Woo! That was a little crazy. Let's try one more. There's only one more problem in this lesson. It's also a greater than inequality. This time John's going to give us just a little bit more work. He's going to give us the original inequality in an unfactored format. Domain equals the integers, so polka dots, no arrows this time. Okay, this is a quadratic expression, but it's messed up. It's not even in proper ax squared plus bx plus c order. It's strewn across both sides of the inequality. Let's start by moving this over here. X squared minus 2x minus 3 greater than or equal to 0. That cancels, right? Okay, this looks clean now. Let's see if we can factor this. And I'll tell you what, I can't speak for the homework because I haven't worked every single homework problem in recent memory. But I'm pretty sure we can factor all of these by inspection. We don't have to drag out the man-eating. We can just look at it. So, two numbers that multiply to minus 3 and add to minus 2, that would be minus 3 and plus 1, right? Yes, I wish you were here to say, yeah, that's right. I can always look at the book, can't I? Yes, that's correct. Okay, so now we're going through that same process again. And I want to point out that last time we didn't. When you're going through this process of setting up these expressions, just let your equation match, or your signs match to the original sign. If your original sign had if your original sign was greater than or equal to, then put the equal to's in these. If your original sign doesn't have the equal to, then don't put it there, okay? So this one, we did not use the equal sign component. This time, we will, because it's in our original expression, okay? So just follow the lead of the problem from there. Now, we want these two numbers to multiply to be something greater than 0. So, both terms could be positive, or both terms could be negative, because two negatives make a positive. So now we've set up the conditions that will yield a greater than answer. So now we don't have to think about this sign anymore. If we want the two terms both to be positive numbers, then x minus 3 has to be greater than or equal to 0, and x plus 1 has to be greater than or equal to 0. Remember that these signs have nothing to do with this sign. These signs are a reflection of whether we want our number to be positive or negative. All right? So we use inequalities in two different ways. Let's set up the other side before we go through and do the math. Okay, here we want them both to be negative numbers, so x minus 3 has to be less than, and x plus 1 also has to be less than. Okay? So again, these minus signs are what are driving these less than signs. These signs don't have anything directly to do with that. Okay, now we have our conditions set up. Let's do the simple algebra. X is greater than or equal to 3. X is greater than or equal to minus 1. And here we're going to add 3 to both sides. Is less than or equal to 3. Okay, I'm going to draw the individual signs. As you get faster and better at these, there's a few shortcuts you can take. You don't have to write the individual graphs. You can just jump to the big graph. But for now, don't worry about fast tracking this. Okay, so here's minus 1. Here's 3. This looks like that. This looks like that. I'm drawing it so we can see both arrows. So our actual solution that works for both conditions is here. And then here's our 3. And here's our minus 1. So this is the actual solution for that. So now we can put it all on one graph. It's from 3 going forward, and it's from minus 1 going backwards. Oh no, it's integers, sorry. So never mind all of these graphs. Let me do them over so you're not confused. It includes the value 0, 1, 2, blah, blah, blah. So this is our first, this is this, and then greater than or equal to 3, right? That would be that graph. So our overlap is here. And the way we would do that here, 4, 5, 6, right? Forget the arrows and just focus on the dots. Does that help it or make it worse? I don't know. Looks like hair. And so what I'm doing is I'm canceling out this and writing new graphs that reflect integers instead of reals. Okay, here we say x is less than 3, 2, 1, 0, negative 1. Okay, so it's equal to or less than 3. So that's this graph. And then this one is just starting at minus 1 and going down. Okay, so that would be here. Minus 2, minus 3, minus 4. Okay, and forget this. Alright, so this is the solution reflecting the proper domain. Sorry if that confused you, but This is the part where your head needs to work. I'm trying to figure out what we're doing. All right? If you have questions, please ask. Again, like I said, in lesson 112, we'll come back and we'll deal with the less than scenarios. These were all greater than, notice? But we're going to use this same kind of format, so you'll get a refresher on that. And hopefully your brain will start to relax and go, all right, I kind of get it. Bye.